cold, distant and mysterious. For decades after its discovery in 1930, little was known about the geology of Pluto.
First seen from the Earth, Pluto is just a very tiny dot, but it was approached by a mission in 2015 called New Horizons.
NASA's New Horizons probe was the first spacecraft to explore Pluto up close, and it sent back some fascinating images.
One of the things that the mission could see was some very intriguing polygonal patterns. And I was like, wow, that's very neat. What could explain these patterns?
The patterns can be seen across the smooth surface of a basin filled with nitrogen ice. Now a team of researchers has a new explanation for Pluto's mysterious polygons. Looking at New Horizons' high-resolution images of Pluto, several researchers were intrigued by markings in the region known as Sputnik Planitia, where dark lines formed geometric shapes several tens of kilometers wide.
When it was first observed, the people that worked on the mission, they very rapidly thought about convection, because thermal convection, in particular in convection in solids, is known to make these type of patterns.
Even though Sputnik Planitia is made of solid ice, slow-moving currents are still the most likely explanation.
Solids, if you look at them on long timescales, behave like liquids. We can see that with glaciers in mountains. We know that glaciers flow down the mountain, so they are like rivers, but very viscous rivers. The ice of Sputnik Planitia is also solid, but it convects on timescales of hundreds of thousand years.
The convection currents that make these kinds of patterns are usually driven by heating from below.
That's what happens when you heat up a pan. You can see patterns, you can see, motion in the pan, and that's caused by convection, because the fluid that is below gets less dense because it gets warmer, and so because it's below and less dense, it wants to move up. On the other side, the fluid that is on top, it's cooler, so it's more dense and wants to go down.
But there was something about the patterns on Pluto's surface that didn't quite fit with the idea of convection currents being driven by Pluto's internal heat.
Heating from below would lead to actually a reversed pattern compared to what we observe. That is, flow going up on the polygon sides instead of going down as we observe.
The visible lines delineating the polygons are troughs, showing that the convection currents must be rising up in the centre of each shape and sinking at the edges, the opposite to what you'd get if you were heating from underneath.
So we still think that convection is at the origin of these polygons, but instead of heating from below, we think that it is better explained by cooling the top.
To explain this cooling, Stefan and his team turned to sublimation. This is the process, similar to evaporation, by which the nitrogen ice of Sputnik Planitia turns from a solid straight into a gas.
This cools down the surface in a very similar way to the situation we encounter in everyday life when we get out of water and we feel cold because water is evaporating, which requires latent heat to do so, and it cools down the skin. And so we think that's exactly what's happening.
To test this theory, the team developed a computer simulation of the surface.
And we found that with reasonable parameters for Sputnik Planitia, we obtained the same type of patterns as what we observe.
Their model shows for the first time that sublimation can drive planetary scale patterns. The team are confident in their findings, but it might be a while before all their hypotheses can be fully tested.
It would be good to go back there and test some of the ideas that we propose, but of course this is very far away and it's very difficult to send missions there. But I'm confident, yes.